Hi, in this video we'll continue with the eToolLCD training focused on infrastructure. In this section we'll model improvements to reduce operational impacts. So we have a list of embodied impacts that we have modeled from the previous training session. Now we'll add a new scenario focusing on reducing operational energy. Notice the energy impact in this example is not the dominant factor because we have reduced the lifespan to 25 years only. So bear that in mind when looking through the results. I'll add a new scenario, and the lighting is the area that we'll focus on with this example. I'll add a new improvement regarding the efficacy, the lighting efficiency. This one will be the LED lighting. It's an energy efficiency improvement. I will remove the factor of safety and create a new scenario. And in this recommendation, the lighting efficiency is increased by specifying LED lighting with the luminous efficacy of higher than 110 lumens per watt. So the improvement is based on underlying assumption that the business as usual efficiency is 90 lumens per watt. So I'm assuming a 20% overall savings by increasing the efficiency of these lamps. But this is very simple. Of course, the LCA, you will interact with your electrical engineers and the lighting design team. And I have a duplicate design here that I'll get rid of. So I'll just focus this one on the starting point, which is my last design that I have modeled. So now I have a new scenario that I can make the light improvements. Before we go into reducing the energy demand, what I want to show you is the lighting template for this example project. So there's a street light, 10 set of the lighting, the luminaire plus the pole, and we'll have a look at the advantage of using templates is that you can consolidate different elements, different components for the lighting system into the same template. So we have people and equipment impacts related to the installation and maintenance of this system. We also have the lighting pole itself, as well as the foundations requirements to install the system. We have fittings, which is the light pole, the lamp, the glass cover, reflector. So very detailed embodied impacts associated with this template, as well as the operational energy. So this system is a combination of two luminaires, one 150 watt and the other one 250 watt, and it's assuming they're running 12 hours a day. So basically what we'll do here, after interacting with the lighting design team, we'll model that 20% savings due to higher efficiency lamp. All you need to do is apply a discount factor here. So multiply this by 0.8 in both annual demand. Do that for the 250 watt lamp as well. Okay, so assuming same embodied impacts, just applying the operational savings. This design will now present us overall savings of 2.59%. So further to the improvement in efficiency, I'll add automation. I'll add some functionality to do with smart controls. I'll add a new improvement, and I'll call this smart street lighting. On top of the efficiency, I'll add automation to the controls. I'll also remove the safety and add a new scenario. So you can add a lot of details to your description. I have a pre-configured description here. So it's assumed that the light 100% output during darkness, which is not a smart way of using the system, because when you don't have pedestrians or vehicles, you're wasting energy. So we have adopted here that with automation, you can dim the lights 20% in pedestrian areas when there are no cyclists or pedestrians. And we can also dim the roadways to 50% when there's no vehicles. Such systems typically achieve a 50% overall reduction, and in this case, just have assumed an additional 30% to be more conservative. The details you can add to the description, so additional benefits, including cost savings in energy, obviously, but as well as inspection and maintenance, with a safer system as well, because you can identify immediate failure of the lamps. You can add case studies and additional documentation and references as well. So what I'll do now, I'll essentially apply the additional 30% savings to the annual demand. Of course, you could be a little bit more precise with this and add the electronics for the sensors and controls, but in this case, just keeping it very simple. I'll just apply the discount factor in annual demand. So an additional 30% savings, I'll multiply by 0.7 in both annual demand for different lamps. So this is the smart street light scenario completed. And this provides an additional 3.11% savings to the overall impact. So we're now getting some operational carbon reduction as well. Back to our models here, we're down to 565 tons. So what I'll do now, consider energy has really shifted down to the 5th impact overall. So I'll add some renewable energy as well, try to bring this energy down to zero or zero carbon, at least for the operational impacts. So what I'll do here, I'll add renewable electricity with solar photovoltaic. I'll add a new template, might have one ready in renewable for solar PV. High efficiency panels. So add that one into my model. It can be installed as a shading device or a rooftop installation. I just defined a starting point for my scenario following the last improvement. And what I'll do, I'll add a 20 kilowatt system. Just add that to the description as well. So it's very clear in the recommendations. Talks about the 20 kilowatt system. Of course, you have to do your generation capacity. This will come from a PV watt or any other solution you use to estimate your generation capacity due to your location, your solar radiation, your shading, your maintenance, all of that, the longevity of your panels, the technology. So just add a template, assuming we are located in Australia for very high solar generation capacity using zone 3, so typical Sydney system. So what I'll do, I'll just add a 20 kilowatt system to my design. So as you can see, significant savings for this example, almost 17% overall savings with the addition of solar PV, and same thing with the template, a template that includes the benefit of producing clean electricity, but it also takes into account the impact of the product. So the important impact associated with the equipment, the inverter, the panels themselves, the framing, and the cabling. So it's accounting for the full life cycle impacts of the solar PV system. So I hope this brings some clarification of the capabilities of the software as well regarding operational savings for infrastructure. And stay tuned, we'll keep bringing you content as part of the training program.